Buongiorno. Mi sentite?
Buongiorno, sì, la sentiamo. Almeno io la sento.
Ok, perfetto. Voi sentite?
Sì.
Ok, allora mantengo così. Inizia la sessione.
Sì. Grazie mille. Grazie. Okay. Hello, good morning to everyone.
Good morning.
Just a few minutes and we will start our session. Nice to see you by video. I'm Fabrizio Battisti from University of Florence, and with me Professor Orazio Campo from University of Rome Sapienza. I think we are all participants because sorry, just I check on my program. Okay. Dedalo, okay. Hello, Dedalo.
Hello, good morning, and good morning, everyone.
Francesco Mercogliano, I don't see Francesco. Okay, Francesco. Good morning, Francesco.
Good morning.
Then Yannis is with us, is here. Yannis, Stefanos. Stefanos, okay, Stefanos. Hello, Stefanos.
Good morning.
Glad to see you. And Diego is with us. I don't see Diego, but probably he's going to connect with us. And then Melania. Good morning, Melania.
Hello, good morning.
Okay. This session merged two sessions of this conference, WACM for S and Digitals. So I think we can start from presentation of Marchetti's group. I think Dedalo will present his work. The title is A Multiple Analytic Investigation of an Earthquake by a Jupyter Notebook, the case study of Amatrice North Italian seismic sequence of 2016-2017. Dedalo, you have 15 minutes, I say, so we have 5 minutes to discuss with the other participants. It's okay for you, 15 minutes of to present your work?
Yes, I will try to keep in time.
Perfect.
Do you see
Let's
my...
go. Thank you. Yes, we can see your presentation.
So may I go right?
Yes, perfect. We see.
Okay, thank you so much to the organizer of this conference to give me the opportunity to present today this study of the Italian seismic sequence 2016-2017 and the development of a virtual research environment in the form of a Jupyter Notebook to study an earthquake like this Italian seismic sequence. This work was done inside the IBOS group, And as you know, in Italy on 24 August 2016, an earthquake of magnitude 6.0 hit central Italy and was the start of a very long seismic sequence. And you can see the sequence of the daily released energy in central Italy. So we see that there was not a previous strong seismicity before this earthquake, and a second, even larger earthquake of magnitude 6.5 occurred on 30 October 2016. And you see here also the map of distribution of the epicenter localized by Italian National Institute of Geophysics and Volcanology, and also two pictures that shows the surface immersion of the slip of the fault from the two main earthquakes that have recorded even more than 1 meter of slip on the surface. And unfortunately, this seismic sequence caused the catastrophic effects on building and also about 300 victims. We have studied the preparation phase of this seismic sequence, publishing mainly these three papers that are on atmospheric anomalies, on magnetic and electron density signal recorded from space, and a multiparametric study of the full seismic sequence. So now we see the first one that is about the atmospheric anomalies. The first author is Alessandro Piscini and is published in Pure and Applied Geophysics. In this paper, we study three parameters: the skin temperature, total column water vapor, and total column ozone, comparing the year of the earthquake, 2016, that you see as a red dashed line, compared with the historical values of the previous year from 1979 up to 2015. And their average, the historical average, is the blue line, and the standard deviation is the blue, green, and the yellow bands, where they represent 1, 1.5, and 2 standard deviation. Then we extract the values that overpassed the 2 standard deviation, classify them as anomalous value compared with the previous year. So we see that on about 11 and 12 July, there was 2 days of persistent anomalies of temperature in central Italy. Value that the temperature is higher than the historical value. On similar days, also the water vapor was increased, and a few days after, also the ozone was increased. And we propose these anomalies as possibly induced by the preparation of this seismic sequence. Also, we compared with historical earthquakes in central Italy, and we found statistical significant the temperature and the water vapor parameter, and less significant the ozone. Then we also studied the data from European Space Agency's WORM mission, which are 3 satellites orbiting from November 2013 and still in orbit, to search possible anomalies in ionosphere for magnetic field and electron density. We published these results also in Pure and Applied Geophysics in 2020. And the main result of this publication was these 2 interesting tracks recorded by Swarm Charlie, 3.2 and 3.7 days before the main shocks of this seismic sequence. So the first one was recorded on 20 August 2016. The satellite passed above the epicenter and recorded an anomaly in central Italy. And a similar anomaly, little larger, was recorded on 26 October 2016. So both anomalies are recorded 3 days and a half before the larger earthquake of this seismic sequence. We are not sure these anomalies are produced by the preparation phase of these earthquakes, but we propose these anomalies as a good candidates. Overall, the one of 20 August was recorded in very geomagnetic quiet conditions. And finally, we also study a multiparametric, we made a multiparametric study of the seismic sequence, and we published these results in Remote Sensing of Environment in 2019. And this picture summarizes the result proposed in this paper that also integrate result from other paper. For example, Gentili, Di Giovanbattista, and Peresan published an analysis of the seismological analysis that by a technique called RTL, and they found a decrease of seismicity in central Italy, so-called quiescence, from September 2015, more or less 1 year before the start of the seismic sequence. We found anomalies in a geomagnetic ground observatory close to the Amatrice earthquakes in L'Aquila, 30 kilometers far. Then we identify anomalies in swarm satellite. And then we found some increase of aerosol anomalies in atmosphere from climatological data of NASA, MERRA-2. And at the same time, Barberio et al. Identify an increase of heavy metal, arsenic and vanadium in water well in Sulmona. And so these are two anomalies that could be caused by the same phenomena identified by different technique applied to different data. So I think they support each other. And then we found other ground magnetic anomaly. And at the same time, also De Luca and other identified a variation in water pressure recorded inside the Gran Sasso National Laboratory underground in Italy. And they proposed that they are induced by some release of gases inside the water. And finally, the anomaly that we already see in a previous slide of atmosphere, and finally the swarm magnetic anomalies just before the start of the seismic sequence of 24 August 2016. So this is a chain of anomalies. And now the present work is to try to develop a platform to analyze, a tool to analyze this earthquake, integrating several parameters. And we propose the integration of data from European Plate Observing System, which is a European research infrastructure that collect data from different disciplines and collect in one platform grouped in thematic core service, TCS. And they are from seismology, GNSS, near fault observatories, volcano, and other research field. So we developed a Jupyter notebook that collects data from European Plate Observing System, integrating also with the European Space Agency swarm data and NASA MERRA-2 climatological atmospheric data. And we see in next slide that after collecting the data, they are processed, extract the possible anomalies, making the plot, and summarize together all the results to search a possible interaction between lithosphere, atmosphere, and ionosphere. So this array was developed as a Jupyter notebook with an introduction, a general introduction about the Amatrice Norce Italian seismic sequence and how to run this notebook. And we provide some global variable at the beginning of the VRA to allow the user to run this tool even on another earthquake if he wants. And here, as the earthquake of the main earthquake were 2, we decided that the epicenter was the average of the 2 epicenter of Amatrice and Norcia, and the time was the time of the first earthquake because we want to study what happened before the earthquake. The magnitude was the magnitude of the larger earthquake, magnitude 6.5 of Norcia, and the fault strike, the direction of the fault, was an average of the two faults that, however, are very similar. And we decided to study 8 months before the earthquakes in the similar approach of the remote sensing of observation paper. Then the first part of the notebook investigated the lithosphere, collecting the data from IPOS platform. And we see some graphs from the tool. That this is the first one, is the earthquake catalog retrieved from the platform. We analyze the earthquake inside the Dobrovolsky radius, which is the preparation area of the earthquake. And we see the cumulative number of earthquake, the cumulative Benioff strain, and then ES parameter, that is the energy of the earthquake divided the square root of the distance of the single earthquake with respect to the target earthquake that we are going to study. And we see that, for example, there is a peak in ES, which is an earthquake not so large in magnitude, occurred close to Bolsena Lake, that is on another fault, but was relatively close to the incoming seismic sequence, and magnitude was around 4. Then we also analyzed the GNSS position retrieved from IPOS platform. And so we collect the GNSS station in Italy, and we select the closer station to the incoming earthquake, dividing from the one on the footwall and hanging wall. And we calculate the relative displacement to search possible tectonic changes before the earthquake. Then we collect the data from NASA MERRA-2 climatologic archive. We retrieved a lot of atmospheric parameter. We detrended from the global warming, for example, for temperature that we see from 1980 to 2024, there was an increase in temperature in central Italy, as is well known, and we remove this trend to search for anomalies eventually related to the preparation phase of the seismic sequence in Italy, and we see below the graph of the cumulative atmospheric anomalies. We apply also a similar approach to the ionosphere, to the European Space Agency swarm magnetic data, and here we see 10 examples of residual track of magnetic field recorded by swarm, and the cumulative graph of anomalies recorded by swarm satellite elaborated by this Jupyter notebook. And finally, this Jupyter notebook put together all the analysis of lithosphere, atmosphere, and ionosphere, with the goal of identify possible similarities between the layer to search for possible geophysical interaction. And as we announced before, this tool is, we want to deploy as a generic and not only for Italian seismic sequence. So we got the occasion that a few months ago, on 23 April 2025, unfortunately, close to the conference site in Istanbul, there were an earthquake of magnitude 6.2 in Marmara region, and the earthquake occurred in the sea, so it's different from the one of Italian seismic sequence with the strike-slip focal mechanism. The Italian was a normal fault earthquake, but we can apply this VRA to this other earthquake. And so we just changed the global parameter, and we did a few minor changes along the notebook to run this tool to this other earthquake, and we can see what is the result of the analysis. So for lithosphere, the new graph applied to Turkey earthquake of 23 April of this year, and we see total different seismicity pattern due to the main plate interaction between Anatolian, Eurasian, and African plates. That is an important plate boundary. And again, the cumulative number of earthquake, cumulative Benioff strain, and the ES parameter, where we see a very large peak that is 35 minutes before the magnitude 6.2 earthquake. There was a 3.9 earthquake that occurred very close to the incoming earthquake. So this is a forest shock well identified by this analysis. And we apply also to the other layer. Here we see an example from the swarm ionosphere, the 10 track of example of residual, and the cumulative graph before the Turkey earthquake. And finally, the most important is the cumulative anomalies of lithosphere, atmosphere, and ionosphere, where we can notice some slight acceleration of the lithospheric seismological data just a few days before the earthquake, and a similar trend in the ionosphere. This is preliminary result, so they need some further analysis to be scientifically confirmed, but we can confirm that this tool can be applied also to other earthquakes. So in conclusion, we identified a chain of anomalies in central Italy before the Italian seismic sequence. We deploy a virtual research environment in the form of Jupyter Notebook that you can download from GitHub using the link or scan the QR code, and run even on other earthquake. We saw today the example of Turkey earthquake, where the platform recalculate all the graphs and analysis just on another earthquake. And I thank you so much for your attention, and I provide you some link if you want to find some other paper or additional information. Thank you so much.
Thank you, Dedalo. Very interesting presentation, very interesting work. I have a question, but before my question, I ask to the other participants if they have any question for you. I can ask you to close your presentation.
Okay, yes.
Thank you very much.
Sure.
Okay. Are there any questions for Dedalo and for his work? So I have a simple question that implicates a very difficult answer, because it's a common question. It's not my expertise, but we can say that are there any connection between climate change or other environmental indicators and earthquakes? And if yes, do you think that will be possible in the future to arrive at some minimal earthquake prediction?
Okay, thank you so much for the very interesting question. And for the first question about the possible link between climate change and earthquake, this is not my area of expertise, but colleagues in INGV are investigating this topic, and they found a possible link between the climate change and the seismic risk. The probability to have an earthquake can be altered by climate change. And this study that I perform on the atmosphere, for example, the change of load of the rain, that could be adding some load on the lithosphere or reduce for less rain than usual. So something that could be induced by also climate change, can also alter the stress on the fault, increasing or decreasing the probability of an incoming earthquake. So the answer is it's yes. And there have been also some recent publication from President of INGV, Fabio Florindo, about this topic. And for the second question is more even difficult, because predicting earthquake have been something that always we hope to do, but very difficult to perform. When something is tried in the past, it success one time and fall the next time without understanding why. And the study that I have done are not done directly to predict an earthquake, and I say it's not possible to predict an earthquake with the tool that I provide. Overall, because we need to know when and where and which magnitude the earthquake was. So it's not possible to apply this tool for a future earthquake without know where, when, and how much will be the magnitude. We need some information from the earthquake. On the other point, I can say that the study of the preparation phase of the earthquake is fundamental to provide some information that are necessary for a prediction of the earthquakes. And I think that with maybe 10 years, 40 years, it will be possible maybe to also predict the earthquake. These studies are fundamental, but not as necessary, but not sufficient to predict the earthquakes.
Thank you very much, Dedalo, for your very precise answer. So, other question for Dedalo? Okay, thank you very much, Dedalo.
Thanks to you.
I think we can move on. And Francesco, are you connected? Yes.
Yes.
Please, you can share with us your presentation. You have 15 minutes to discuss your work, then 5 minutes to question, comments, and others.
Okay, do you see my screen?
Yes, we see.
Okay, perfect. Okay, good morning, everyone. My name is Francesco Mercogliano. I am a second-year PhD student at the University of Naples, Partenope, associated with the Institute for the Electromagnetic Sensing of the Environment of the National Research Council of Italy, the ICCSA. And as you can see from the presentation title, today I will be discussing about a geophysical survey we conducted to test new drone-based geophysical technologies that have been recently acquired by the CNR IREA Institute, together with the Italian Integrated Environmental Infrastructure System, the ITINERIS project. So the main goal of our study was to test the newly acquired drone-based geophysical technologies and to validate the results obtained from these technologies operating under various configurations. I will start briefly by describing the area in which we decided to take our survey for the drone testing, and I will explain why we chose this particular area for our tests. Next, I will provide an overview on the geophysical technologies used, which are the Magnimbus magnetometer and the Zone D RLF GPR. And then I will show the data collected from these two technologies and how, after the data processing, we were able to obtain the vertical gradient map and the filtered radargrams from the magnetometric data and the GPR data. And then I will conclude with the concluding set, some future developments. In the last decade, the rise of unmanned aerial vehicles has revolutionized geophysics. Consequently, several geophysical sensors have been optimized to be enough compact and lightweight to be mounted as payloads under these vehicles. This resulted in a facilitated data collection, expanding it even in accessible areas, thereby enhancing spatial coverage and the spatial resolution, and significantly reducing both the physical efforts of operators and the survey time with respect to the common ground-based surveys, while still ensuring good quality data sets. As mentioned earlier, the testing survey was carried out at the Altopiano di Verteglia, which is a small tectonic cast basin located in the southern Apennines in southern Italy. This area has been previously surveyed through some geophysical ground-based methods. In addition, magnetometric measurements conducted both in ground and drone-based configuration confirmed the presence of three varied shallow metallic pipes. So the prior knowledge on the area and its detectable targets made it an ideal location for our survey aimed at testing the newly acquired drone-based instrumentation. As for the drone-based magnetometric survey, this was conducted using the Magnimbus system, which is a magnetometric system equipped with two Cuspingen 2 atomic sensors placed at 1.7 meters of distance, and which are able to acquire the total magnetic field. So for each acquisition, the Magnimbus system acquires two values of the total magnetic field at the same time. This easily allows the evaluation of the vertical gradient. the possibility of a gradiometric configuration within magnetometric measurements is a significant advantage. This because the vertical gradient benefits from several properties. First of all, the vertical gradient is insensitive to temporal variations of the magnetic fields. This because we consider two acquisitions of the total magnetic field at the same time, so no magnetic references are needed. Moreover, the vertical gradient has an increased sensitivity to shallow sources and a less sensitivity to magnetic regional fields. And also, vertical gradient has an increased ability in distinguishing signals coming from nearby sources, so has an higher resolution. Moving on to the details of the survey, this was conducted in the eastern part of our test site, and the Magnimbus system was mounted beneath the DJI Matrice 300 RTK drone. The flight was pre-planned and executed using the UGCS Pro software, covering an area of approximately 30 by 120 meters, with flight lines oriented along a north-northwest, south-southeast direction, spaced 2 meters. The drone flight with a speed of 2 meters per second. And also, it is important to say that the drone flew with the true terrain following features, which essentially allows the drone to fly with a constant elevation above the surface, thanks to the presence of a laser altimeter, which is the NRA24. And in this case, the altitude was set at 5 meters above the ground level, allowing the Magnimbus to acquire two values of the total magnetic fields at the altitudes of 4 and 5.7 meters, respectively. Moving on to the drone-based GPS survey, this was conducted using the Zondia Aero LF, which is a single-channel GPS system equipped with unshielded dipole antennas. Usually, it comes with a set of 3 center frequency antennas, 100, 150, and 300 megahertz. For our purpose, we used the 300 megahertz antenna operating in the bandwidth between 150 and 600 megahertz. And being the system extra lightweight, it was suitable to be mounted under the same DJI Matrice 300 RTK drone. Even in this case, the survey was conducted in the eastern part of our test site. Flights were planned and executed using the UGCS Pro software. Specifically, it covered an area of around 10 by 40 meters, with flight lines oriented along a north-northwest, south-southeast direction, with a spacing of 50 centimeters and a flight speed set at 1 meter per second. Even in this case, the drone flew with the true terrain following mode, keeping a constant elevation above the surface of 1.5 meter. Moving on to the results of the two drone-based surveys, starting with the magnetometric results, here are shown the unfiltered total magnetic field maps obtained by the two sensors of the Magnimbus, which acquired data at the altitude of 4 and 5.7 meters, respectively. What is possible to see from these two unfiltered magnetic maps is the presence of two main magnetic anomalies. But what is also possible to see is the presence of a strong heading error, which is related to the acquisition mode of the Magnimbus. Specifically, as we mentioned earlier, the drone flew with the true terrain following mode, which allows to keep a constant elevation above the surface thanks to the laser altimeter. And the heading error is essentially related to the position of the laser altimeter, because the laser altimeter is mounted at the bow of the drone, always facing forward, making a rotation between each acquisition line necessary. So between each acquisition line, the Magnimbus system rotates because the laser altimeter cannot look backward, and so the Magnimbus sensors have a fixed orientation, and this results in a strong heading error. We processed the unfiltered total magnetic field maps applying several processing procedures. First of all, the removal of the international geomagnetic reference field, and then the heading error removal. There are several approaches for the hidden error removal. We simply removed from each acquisition line its median value. Then we also applied a low-pass filter. After that, we then evaluated the vertical gradient map. Here is shown the filtered vertical gradient map. What is possible to see is that the vertical gradient shows very good results with a very enhanced resolution. It is possible to see the presence of three main magnetic anomalies respect to the only two main magnetic anomalies that were visible in the filtered total magnetic field maps. Moving on to the GPR results, here is shown the raw radargram coming from the full flight of the Zone D IRLF GPR system. For our purpose and our discussion, we considered only a radargram coming from a single survey line. What is possible to see from the raw radargram is that signal coming from the targets of interest are masked. This is related to the strong ringing characteristics of the Zone D IRLF and due to the lack of antenna shielding. So this makes essential filtering procedures in order to highlight any signal of interest. So we applied some standard time domain filtering procedures, which are the zero timing and the background removal for clutter removal and the time gating. And in the filtered radargram, it is possible to see the presence of three main diffraction hyperbolas. The first two, one at x ranging between 5 and 15 meters, and a third one at x ranging between 30 and 35 meters. So, in conclusion, our study involved a comprehensive test of two newly acquired geophysical drone-based systems, the MagNimbus magnetometer and the Zone D IRLF GPR system. This evaluation provided significant insight into the potential and performance across various configuration and operational conditions, identifying any limitation to overcome in the future. Essentially, the MagNimbus, as we previously said, can be considered as a natural gradiometer since it is composed of two sensors placed at 1.7 meter distance, and that easily allows the evaluation of the vertical gradient. And as we previously said, the vertical gradient represents a significant advantage within magnetometric measurements because it benefits from several properties. But the most important one is that the vertical gradient is able to distinguish signal coming from nearby sources, so it has an higher resolution. And this is possible to see in our test because in the unfiltered total magnetic field map, we were able to see only two main magnetic anomalies, while in the vertical gradient map, we are able to see three magnetic anomalies, which are related to the three buried metallic pipes. On the other end, the adopted flight configuration of the MagNimbus leads to a hidden error, a strong hidden error, which leads to a strong processing to mitigate its effect. On the other end, the Zone D IRLF, the drone-based GPR system, is equipped with extra lightweight unshielded dipole antennas, which allows the GPR to be mounted under small-sized drones, allowing to a stable flight and with less battery consumption, respect to some other drone-based GPR system, which usually has to be mounted beneath bigger sized drones, so with a higher battery consumption. However, the lack of antenna shielding makes data processing more complicated. This because the backscattered echoes comes from a broader radiation pattern. However, the processed radargrams, as this case shows, allows the identification of the three buried metallic pipes through the three diffraction hyperbolas we see in the filtered radargram. So the experimental UAV-based results confirm the advantages offered by the joint use of both the methodologies, allowing an accurate localization of all the buried metallic pipes. Before concluding, I would like to highlight that this can be considered as preliminary results because future development will include the inversion of the GPR data in order to obtain a three-dimensional reconstruction of the investigated scenario to be integrated with the magnetic data imaging for a more complete and accurate characterization of the studied area. So thank you for the attention.
Thank you to Francesco for your presentation. And as usual, I ask to other participants if they have some questions for you. I have a consideration. My research activity focuses on plan and program evaluation, and understanding geological phenomena is crucial and fundamental and prodromal component of planning. So, could your study with drones go so far as to give information that is a substitute for traditional surveys? Because this could be very useful for land use planning, for example. If drone studies can substitute or not traditional surveys.
But I don't. This maybe be let's see. I don't know if personal question, because from my personal point of view, I
Yes,
think
yes,
and
your personal point of view, just your personal, a comment, your
I
personal
think
comment.
yeah, I hope that the drone service will never, let's say, substitute the common ground base, because it's, I think I like to take the measurements by myself sometimes, but it's of course like a strong revolution, especially as I said, in some inaccessible areas, because in some cases, let's say that it's very difficult to go and take the and collect the data by yourself, because some areas are difficult to reach. So in this case, the drone acquisition can be very helpful.
Thank you, Francesco. Other questions? So we can go on with Yannis Paraskevopoulos and Stefanos Zignidos presentation. Stefanos, okay, you present for your group. You have, as usual, 15 minutes and then 5 minutes for questions and comments. Thank you, Stefanos.
Thank you so much. Thank you so much. Can you hear me well?
Yes, yes, we hear you.
Perfect. Okay, give me one moment, please, to share my screen. And
Please. Okay.
here we are. And please tell me if you see my screen on.
Yes, yes, I confirm that we see your presentation.
Perfect, perfect. Thank you so much, and it's an honor to be here with you. And it's also very interesting that while the topics are different, we might find something interesting between so different approaches. And I would like to move the discussion to something pretty different than the two previous authors that went nicely on earthquakes and magnitudes and all these kind of geophysical aspects. And I would like to now present something really different about urban governance and policy. So we move our interest to cities and how we can apply planning initiatives that help building inclusive and sustainable cities. So one first concept that I have to describe is that it's time to integrate planning. And as we know, planning is something very diverse, very complex, and we need to understand all these difference that it is embedded inside the process of planning, and also to understand how different perspectives like mobility, transport, urbanism, all these kinds of different phenomena that we have in our cities, for example, all the risks, and I would like to connect with the previous presentations. For example, we have these kind of risks of earthquakes. How can we replan cities? So it's like of an urban problem. We can see floods and all this flooding risk. So it's not only about what people do in the cities, this kind of integrated planning, but it's also about the environment, the natural and the built one. Furthermore, we should notice of participation. We should consider participation right now. And also the final one is the evidence-based, because traditional planning used to be based on intuition or on theory, but now we need evidence. So it's really, really important to take quantitative and qualitative methods to integrated planning. But to do that, we have to build a network. And what we mean by network, we mean a platform or an association that combines other associations, other cities, other universities, in general, living labs, or somehow groups of people that address cities problems and also address any kind of planning. So it's like we need a transnational network that goes beyond boundaries and adopts somehow an integrated approach of discipline, method, and roles. So we need to bring together different disciplines like transport, mobility, urbanism, other kind of planners, to also integrate methods, quantitative, qualitative participation, and last but not least, to integrate roles. Because in a city, in a diverse system of cities, we have the universities, we have the planners, we have the companies, we have the NGOs, we have people's groups, we have active society. So we have to bring them all together in such a network and facilitate a different way of planning our cities. That's our goal from this survey, from this study. And our study is based on a European research project, an Erasmus Plus project that is called Impla Labs. So we aspire through our project to build a network and to establish its foundations. So our vision is to build a leading network that brings together all this ecosystem and formulate a new way of how we teach planning. Because without collaboration between different cities and different roles, without participation, without knowledge co-creation, it's really important. And I would like to note that again, that when we see different things, we don't have to be afraid. Like, okay, one is doing about, for example, geophysical sciences. Another one is doing about people. We might find the right solution to convert them, to interact with these different disciplines. That's the beauty of integrated planning. So we need to upskill the planning actors. For example, a policymaker or a decision maker should gradually try to understand active society or universities. And another very important remark is that we need to cultivate an integrated planning culture. And finally, to build a long-term hub, because our network, okay, we built it in the context of our research project, but we need to last. We need this network to last. We need this initiative to continue, and that's a challenge. That's a major challenge. What you do to build continuity and to give prosperity into such networks. So let's dive into the foundations to not waste any more time on theory. What we need when we build a network, we need a charter, we need a hub of knowledge and a participation guide. Our presentation will only focus on our charter and why we need a charter. Without it, we can't govern our operation. So, and every organization has a charter. But I have to note that through our literature review, we found that many planning organizations meaning that organizations that bring together planners that change our cities, change our neighborhood, change the way that we govern the cities and we build them, they do not have clear objectives and clear principles about integration of different concepts. They just focus on their own. So at first sight, it would be very reasonable to do that. But if we do think about the complexity of our cities, then we need to take integration into account. That's why we have to develop a clear charter that will give guidance for action. It will also be very important to distinguish member rights and duties. What can we do with what we cannot? What we should give to these kinds of network as members. Also, transparency to be something that anyone can see, anyone can criticize, and anyone can improve in the future. To be legal recognized, otherwise you may have some recognized problems related to the entity, the entire entity of the network. To ensure sustainability and continuity, because without the charter you cannot facilitate the process of the network. You may fall into a trap of an isolation, but with a charter that is clear, that is transparent, you may go further. And the last one is to be credible. With a charter, you can get credits, you can get trust of the members, you can get trust of other associations that you might speak, for example, with the government, or for example, with local administration, and all this stuff. So we need the charter. When we build a network, we need the charter that should reflect the principles of the network. What we did, our methodology, it was a very simple but very, very thorough methodology of literature review. That what we did, we reviewed 25 associations that work on planning. So we distinguished what we mean of all these kinds of associations that build cities and that govern cities, and we focused on what was really essential, on associations related with planning. So after that, we screened the documents to find out if they're available, if we can read them, if they are in different languages. So is it possible to translate them? Of course, we cannot know any language in the world, but it's easier to shed light on some languages that you may have a connection before. So we screen the document and then we analyze them thematically. And through a qualitative content analysis, we determined key criteria for our network, for our charter. That is really the contribution of that study. How, from literature review that is really, really thorough and detailed, you derive into the some insightful results. So to continue, our results is that we build a charter, and the charters, as I said before, are very essential for organizations. And our review identified 4 main categories of the charter that we should fill in. The first one is the mission, very, very important. The next one is governance, how you govern these kinds of associations, how you accept members, how you delete members if needed, how you try to understand their rights, and how you try to be inclusive. This is very important. And another very crucial thing is about the content. What you have there, what you include, what topics you work on. So we found also some key remarks about the content. And the final one is the logistics, or like the principal things and points about the address or the name, or things that you have to take into account when you establish an organization somewhere, because you need to have a base. So through that 4 categories, we integrate, we somehow managed to build this charter. And any one organization has to draft the charter, and ours is that one. So our key terms is integrated planning. I'm mentioning that once again, we bring together different roles, methods, and people, and to formulate a network. So we have a name, we have the objectives, the vision, the purpose. It's really important. We have the address, membership, and membership really matters, and the rights and duties. These all kinds of the boxes that you see, we fill them from now on from the research project. But when our network continues, and as the network continues, we should also decide more concretely about the management and administration, the representatives, elections, assemblies, and all these kinds of administration that needs to be done when you want to operate in a democratic way, in a clear way, and in a transparent way. So this is our charter, and we may see some examples. You can see that our purpose is to facilitate knowledge exchange, collaboration between different researchers and different actors, and capacity building activities. What we mean by that is that we bring together all these kind of actors that are members in our association, and they can work on a specific subject. They can integrate new perspectives. They can also propose things that matter to them, and they need to deal with them, and also to interact. We really need interaction, and that's a very important thing, and that's why I'm happy to be in a such diverse session, because we may see similarities beyond differences. So we have the membership. It's very important that our network is inclusive and welcomes both individuals and associations. It's a bit tricky, that one, but we really need individuals as well. We really need to hear the voice, to provide them the space that they can interact with others. And also, we think that it's in the yellow boxes, this one, the last, but we think that executive committees and thematic committees are the key to success, because thematic committees distribute the work, distribute the interests, and work accordingly. So to conclude, we think that organization and interaction is the key, and this kind of remark I want you to keep, to remember that different kind of planning, different kind of associations, they might need to come together. Otherwise, we may fall into the trap of being isolated, being separated. So it's not only about planning cities from our perspective alone, in a standalone approach, but to come together. And I will say an example that came to my mind listening to the previous 2 presentations. At first, we may see that it's different to have engineers and planners, and they cannot meet. But we think, through our study and through our work here in Athens and in the European level with this project, we think that even really different disciplines can come together. And if we have a city, and there are risks of somewhere to have distractions in roads or in the buildings, then we need to come together with other disciplines. We need to know all these very interesting pieces of literature about the risks of the physical environment. So a network could facilitate that. Our network has this charter. This is the foundation. This is the very, very first step of building an inclusive and sustainable association. We of course, acknowledge the need of refinement in the future, It's an initial approach, but without having something to start, you cannot proceed. So to conclude, we need to bring different actors. We need to understand planning as an integrated process, and we need to come together to be at the same table, or physically or digitally, like us right now. And through that one, this is the only way, or at least one of the most significant ways, to build sustainable cities that they do not fear of risks. They somehow anticipate them and deal with them, and also to give room to anyone that wants and has the time to create solutions for their cities and their neighborhoods and their regions. So thank you so much for your time. If anyone wants to join this network, is about spatial planning mainly, but who knows, we can also add different disciplines, different ideas, and bring together different thoughts and approaches. And so thank you so much. I hope I was on time.
Thank you, Stefanos. Thank you, Stefanos, for your work and your presentation. I ask to the participants and to the physical participants in our room if are there any questions, comments? Hello? I have a question.
Mhm.
The charter, about the charter. Should the charter, in order to have legal effects, become a law, a rule, or regulation? And should the charter be updated periodically?
Thank you very much. That's a very, very important question, and I'm really happy to hear that, and I'm really happy to answer. First of all, as I said before, we are doing that kind of experiment. I would characterize that, because it's like an experiment through a European research project. So we didn't, until now, we haven't get into that kind of legal recognition, but we know, and we have come into some first kind of discussions with the legal part of the university, or in the legal part of other consultants that may help us. And after the finalization of the project, in order to be sustainable and to continue, we should ensure that. So we really need to have a pretty firm legal recognition, like a stamp. I'm doing this kind of movement to seal our work. So we really need it. And if we think about our pan-European, as a start pan-European range, we need to think of a way to be legally covered in a European level, not only in the Greek context. Because right now, National Technical University of Athens is leading the project, but after that, the network could become a European initiative. So we couldn't only work on a Greek context, but as you said, that to be legally covered in a more broad and a more inclusive way. We are working on that. And thank you so much for this question.
Perfect. Thank you very much. So Dedalo has a question. Please, Dedalo.
Yeah, hello. It's just a short comment that's, as you mentioned, like also our previous presentation, I want just like to give my availability if you want to have also interaction and I am also work inside the European like consortium in research infrastructure. So like this is legally recognized, for example, and maybe there could be, I am not like a leader, so, but for what I can do on my point, if you want to have also future interaction, we can keep in touch. So just provide my availability, and thank you for your very interesting presentation.
Thank you very much. Really appreciate that. I have the contacts. We may keep in touch. Thank you so much, and really congratulations for your interesting work. I couldn't ask something because I don't have this kind of expertise, but I really think that knowing all this kind of, for example, earthquakes, we may find it useful for urban planning as well, because they are not isolated. We should come together, and that's the beauty of planning. You know something, and then you deal with it. Thank you very much.
Okay, thank you, Stefanos. Thank you, Dadalo, for your comment.
Thanks.
So I think we can go on, and Diego Brandao or Danilo Mauricio, Pedro Enrique Gonzalez, someone of you is here with us. Rafael Guerra, Yader Lugon Jr., and Maya Romai. Is there someone in this room? No, I think no. So I could say go on, and then we will see if Diego or other participants will connect. So Melania.
Yes.
Okay. So
Okay.
we can go on
Present.
with you, so you can start your presentation. 15 minutes.
Yes.
Then 5 minutes for comments and suggestions or questions.
Okay. You can see my screen?
Yes, we see.
Okay. So, good morning, everyone. I am Melania Perdonò, a research fellow at the Department of Architecture at the University of Florence. And today I will present a study on the subjective aspects of settlement choices with a particular focus on the tools used to identify housing preferences along Professor Fabrizio Battisti. This topic is become more significant amid digital transformation and ongoing urban changes. Okay. This work is a part of a pre-2022 project funded by the Ministry of the University and Research. And in particular, this project aims to analyze current and future housing needs to inform urban regeneration policies and territorial governance. Specifically, it examines housing mobility, which can have a significant impact on planning, land use, and rural environment. Our research begins with the digital transition, which has brought about a significant shift in lifestyle and living arrangements, creating new challenges and new opportunities for spatial planning. In particular, nowadays, we increasingly work, shop, and connect remotely. Now, in this slide, we illustrate some data. In particular, by 2025, smart workers in Italy are projected to reach 3.7 million. Digital consumers number over 35 million, and there are 42 million social media users who spend more than 2 hours online daily, with streaming spending around 7 billion euros. So these statistics indicate that the physical residence is no longer necessarily aligned with the workplace or to the access to services. Consequently, living becomes a more flexible choice, often driven by personal well-being rather than functional necessities. Housing mobility now, in this view, has a broader meaning. It's no longer just driven by economic or employment needs, but can serve as a tool to enhance quality of life. The digital shift creates new opportunities to rethink living arrangements and location aligned with the European goals of personal well-being and sustainability. This trend is expected to expand in the post-pandemic era and greatly influences territorial governance. In particular, it calls for moving beyond traditional planning models and demands innovative tools to can capture people's desire, perceptions, and expectation. Understanding housing mobility today involves recognizing subjective motivations, and so not just economic or logistical factors. In this view, we chose to emphasize the subjective aspect in settlement choice. As mentioned earlier, quality of life and housing well-being are influenced by three key dimensions: the economic dimension, the objective dimension, and the subjective dimension. In particular, the third dimension, often overlooked, helps us to understand which areas are considered livable beyond just market value or available amenities. Our survey specifically aimed to capture and analyze this aspect by gathering preferences directly from residents. So, to analyze the subjective dimension, we used an online structure questionnaire. In our study, 130 Tuscan individuals completed a questionnaire on housing preferences, which is divided into four sections. The first section of introduction and instruction for independent completion, the part of socio-demographic data, as when we ask the age, the household type, housing and work, the part of well-being and satisfaction, general and place related, using linked scales and open questions, and the part, the concluding part of future perspective, that where we ask the desire to move, the obstacles, and the ideal location. This design helps respondents answer the questions in a logical order, moving from general to specific. This approach reduces their answer. So, as I say, the sample included 130 individuals from urban and rural areas in Tuscany, and the data encompass a range of ages and living arrangements, such as 38% living with their partner, 29% with their family of origin, and 33% living alone or cohabiting. The tertiary sector is the most common among employed participants, highlighting the increasing importance of digital transition. So, this questionnaire explored perceived well-being generally and by residents, using a Likert scale from 1 to 10 to rate life satisfaction and satisfaction with current residents. Results show that 45% are satisfied with their life, but satisfaction with resident drops, especially in larger cities like Florence, Pisa, or Prato, which receive lower scores. Rural or peripheral residents express more satisfaction, and this suggests other factors beyond city services affect perceived livability related to subjective well-being. Respondents described the positive and negative aspect that we illustrated as a keyword cloud. And in particular, the positive aspects include environment, greenery, cultural heritage, and services, also serenity and human scale. In contrast, negatives involve poor infrastructure, traffic, high cost, and noise, anonymity, and lack of green spaces. Overall, perceived well-being links to material factors, feelings, expectation, and relationships. So then we examined the wish to change the residence by asking if people want to move and if they could. Over 50% want to move, but many say they cannot afford it. Reasons include financial constraints like mortgages, high rents, job insecurity, emotional ties to family and social networks, and fear of losing stability or fitting in. This data shows a gap between the desire to move and the actual ability, which housing policies should address. Then we asked if you could live anywhere, where would you go? And a very interesting fact emerged. Big cities have a little appeal. Only 9% of respondents would choose them. And conversely, the most desired destination are small towns and villages, chosen by 31%, and rural or natural areas, chosen by 24%. Only 12% would consider to moving abroad. In general, most people prefer to stay within their own region, but move to less dense, more livable areas and with better environmental and social qualities. And this confirms a clear trend. Today, the ideal home is not in the metropolitan center, but in a human scale environments where time, space, and nature play a central role in a daily life. Thus, at the end of this questionnaire, we asked participants where they could move to. The slide illustrates the residential preferences throughout the region of Tuscany in the form of a thematic map created on the basis of these responses. In particular, red areas are perceived as repelling, meaning context from which people wish to live. And in contrast, green areas represent the most desirable regions, attracting those who wish to change their home or lifestyle. It is important to note that the size of the buffer reflects the number of preferences expressed. The larger the circle, the more people have identified that area as their place of origin or the place of destination. Therefore, this map shows not only where people live, but also where they would like to live and where they would prefer to live from. Some results are very significant. In particular, the most dense and congested urban areas, such as Florence, Prato, Pisa, are regarded as undesirable. These are the red zone, the areas from which many would prefer to move. The reason for this are related to the cost of living, traffic, tourist pressure, and low perceived environmental quality. Conversely, less urbanized in island region, such Casentino, Alto Mugello, and Valdorcia, as well as the southern Tuscan coast, stand out as attractive areas. These areas have a good landscape and environmental quality and are considered more livable, even though they often lack services. This kind of analysis enables us to create an alternative geography based not only on economic or functional indicators, but on people's expectation and desires. A map of settlement desire could be a useful tool for territorial planning, particularly for regenerating island areas and for reducing urban congestion. So, at conclusion, our survey results clearly indicate that many people wish to change their residence, but are often hindered by financial or emotional reasons. There is a noticeable preference for quieter, greener, and more human-scale environments over large cities, which are now seen as less livable. These findings highlights that spatial planning should consider not just statistical data, but also people's perception and their desires. In this context, tools like our questionnaire serve as a valuable support for public authorities, aiding them in understanding housing needs more deeply, guiding more target policies, and creating genuinely desirable and inclusive communities. So, at conclusion, I want to conclude this presentation with these words. Housing policies must support not only access, but also the quality of life people seek. Understanding desires and constraints is key to socially sustainable territorial transformation. Thank you for listening.
Thank you, Melania, for this presentation. I am co-author, so I leave our participants to make questions, comments, suggestions for our study. Professor Campo is with us, member of this research group, with this research unit in Sapienza. Okay, Melania, could you stop the presentation so we can see? Stefanos, please.
Oh, thanks. I would like to thank you for that very interesting presentation, and just more of a comment and an idea maybe. These kinds of work are really important because we see that today especially people can move more easily, so they are really needed. So I would like to congratulate you about this very interesting work and very essential work for the future. One idea could be to take all the survey that is like the perceived somehow way of moving and compare it if you find actual mobility data of interregional mobility. For example, I worked in 2011 in somewhere in Tuscany, but I changed in 2021. So if you find also the real data, actual data, you can do a very nice comparison of how people think of moving and if they actually move. That would be incredible because you have made such a nice map and such a nice somehow organization of the questions that were really helpful. And for me, that okay, I have been to Italy several times, but I really understood how this kind of region works and how people move and where they want to go. And one more, it's really interesting that people don't want to go to big cities. Wow, it's surprising. It's reality though. They all want to go somewhere more healthier, more livable. And that could be another idea of how to propose measures in your area or elsewhere that can help people to really relocate to different areas. Because we have also the same problem in Greece. We have many mountainous areas or islands that are really beautiful, but they are only for tourists or for no one. So we try to find ways populating these areas, not only in the summer, but throughout the year. So thank you so much. Very, very interesting presentation.
Thank you.
Thank you, Stefanos. You focus on our goal. We have a lot of large areas without inhabitants. And so with digital transition, these areas could be populated again. So I would like to give you just a number. For example, in Florence, to understand that our vision is a future vision, it's not actual situation. Because, for example, in Florence, we have 300,000 of inhabitants, but 500,000 of city users. So today we have the inverse phenomenon. But we hope that in the future, with connection, with digital transition, these numbers could be inverted, for example.
I see.
Thank
I
you
see.
very much for the
And
question.
it's great. It's
Yes.
great. Thank you so much for the response.
We have a question in our room.
You have to come closer. I don't know if they lo decidiamo from centro.
Ah, sì, sì, okay, yeah. Okay.
Thank you, Melania, for the presentation. It was very nice.
Anyway,
Sorry. Thank you.
came to our table chat.
I'm Alessandro Ralli. I work in Nice, in France, and I've seen a lot of works in this kind of mobility, residential mobility, also intentions, as you did. And I have a first technical question, because maybe I lost it during the presentation because of the connection. And I was interested into if you ask also what is the residential type of the people that you ask the questioners, like are they living in houses or apartments, and which is the size of their houses and apartments?
Okay.
Yeah. The sample representatives of the people we interview.
The type of interview are selected casually. We do not identify the household type as apartments or the type of house, but we selected an household type with considered the mi viene la parola.
We also for desires we ask to people casual, with a sample representative of, without considering the revenue, the regional condition. But we did another part of this research for market value and debt to income ratio to understand where people can live, not to live, but where people can live, considering their revenue, and we separate population considering revenue and social status. But this kind of separation of population of sample of interviews is only for the part of research that focuses on market value and possibilities to rent or to buy an home. For the desires, we ask people, but without considering the age, the job, or other social, for the moment. For the moment.
Because I've seen a
The
study.
research is in progress.
Okay. I mean, it's already a good job that what you did.
Thank
I've just
you
seen
very
a PhD student that collaborated with us, and they try to segmentate the surveys depending on if they were living in a house in a compact neighborhood or in an apartment in a compact neighborhood, or vice versa. It was a house in a low density neighborhood or an apartment, because depending on that, she noticed that, of course, the idealization of the potential choice could be different. And so that's why I was curious about this condition. But anyway, I understand that it's a potential.
We can share our contacts, Melania, to join
Yeah, of
our
course, of
research
course.
and to collaborate for future
It's interesting.
improvements.
And of course, there's also the the second aspect of the social representation that are strongly impacted by the current discussion about the environmental
Yes.
desires and everything. So I was wondering, how do you measure this kind of influence of the idealization of where we have to live, but then we don't have the actual conditions? How do you compare these two aspects?
I can say that we have ascertained that the desire to move abroad concerns the great part of population. Population with low income, population with not beautiful flat or apartment. So this is one aspect that we are studying, but the first results is that people with difficulties to live probably desires to move on. People with good revenue, good job, good status,
They like where they are.
they don't like to
They
move.
enjoy the
But
life.
this is only the first results. We are studying, we have to segmentate in future as further improvements of our research. You give us a good suggestion.
It's also close to what Stefano said. Sometimes the actual mobility patterns, the residential mobility patterns, and the desired mobility patterns are like diverging. Like,
Yes.
I noticed that also because I work with commerce. When you ask people where do you want to buy your fruit and vegetables, everybody, like 80% of the people says local groceries, like bio groceries, etc. But then when you the actual expenditure is in large surfaces. So there's a divergence that is made by the actual current discussion about the environmental.
For our point of view, the market, the real estate market, is the most important aspect that, as you say, these divergences between what I would like to do and what I can effectively do.
Okay.
For our point of view, in this moment of the research, this is the most important. But within that knowledge as what can I say, as a tool to understand, to reflect about personal situation, can what can I say, enlarge the knowledge about the life in other parts of the territories compared to cities. And then in the future, I think that probably some part of territories with accessible houses, accessible market value could be explored, could be discovered.
Yeah, how to match the desire with the
Yes,
the actual-
matching the desire with
the
the
actual
market
possibilities
value,
of the
market
territory.
real estate.
Okay. Thank you. Very nice
Expectations.
presentation. Don't want
Thank you
to
very much.
take the
Thank
time
you
for
very
other
much. Thank you
presenters.
very much. So I see Danilo Mauricio. Danilo, I see you. I don't know if Danilo has some problem with connection. We can wait 5 minutes to see if Danilo can join us. So we're approaching to the final session of this conference. So in 20 minutes, the last session, the final session will start. So we have to finish our session. Sì. Danilo Maurizio.
session is closed.
We are waiting for the last participant, but Danilo Mauri, so that he has been connected for 2 minutes, but now he's offline. So I think we can close the section because timing is important. So thank you to all participants to join this session. Very interesting works, research works. I hope that this section could make a connection between us for improvements of our research. So greetings from me and Professor Campo. And if you want, you can connect to the final session of this conference. Thank you very much, and I hope to see you again in other conferences.
Thank you so much. Bye. Bye, everyone. Bye-bye.
Bye.
Thank you so much. Bye-bye. Have a nice day.
Thank you, Rachele.
Se quello che deve presentare non presenta,
Beh, ormai direi di no, insomma, poteva connettersi.
però magari può inviare, giusto per non perdere il fatto che ha partecipato, per ricevere l'attestato, può inviare la sua presentazione, magari la
Magari tanto, insomma, non è
perché
che
peccato che...
non è che mi metto a segnare assente, magari
sì, appunto.
ecco.
Per questo non
Diciamo, tanto era registrata la presentazione?
Registrata,
cioè chi vuole può vedere la registrazione delle
Sì,
sessioni,
sì.
ok, quindi lui non compare, insomma, abbiamo chiamato ma non compare.
Sì, però non importa perché ci
Ah.
sono stati dei problemi tecnici, per esempio l'altro giorno abbiamo fatto una presentazione con WhatsApp.
Ok. È connesso ad un certo punto, poi si vede, lui credo dal Brasile si connetta, forse era anche molto presto, perché sono le 5 di notte in Brasile, quindi alla fine... Vabbè, comunque, semmai poi scriverò io, insomma,
Sì.
non so più. Mandare la presentazione a no,
No, solo per vederla voi, solo per vedere, sì, perché
Che
voi
ci
siete in che segnate.
Ah, ok. Va bene. Grazie mille, alla prossima, grazie. Qualcosa devo un po'.